Hello guys, in this video I'm gonna show you that square root of 2 is irrational. So square root of 2, and I want to show that it's irrational. So the way I'm gonna prove it is I'm gonna assume the opposite. So I'm gonna assume that it's actually rational. So it can be written as a fraction of two natural numbers p and q. So I can assume that it's a fraction of two natural numbers because square root of 2 is positive, right? So I'm gonna assume that it's a fraction of two natural numbers, and then gonna try to get a contradiction, and that's how I'm gonna prove that it's actually irrational. So I'm gonna assume the opposite right now. So I'm gonna assume that p and q are in natural numbers. Okay. Moreover, I can assume that p and q, only one of them is even. Why can I assume that? Because if both of them are even, then I can divide both numerator and denominator by 2, and I can keep going until only one of them stays even. So I can assume also p and q, only one of them is even. Okay, I can also assume that, right? Okay, alright. So now let's start working with this equation. Square root of 2 equal to p over q. Let's raise both sides to power of 2. I get square root of 2 to a power of 2 equals to p2 over q2, and then I conclude the square root of 2 to the power of 2 is just 2 equal to p2 over q2, but I'm gonna just bring q2 to this side, right? Equal to p2, right? So I'm just bringing q2 from this side of the equation to the top on the outside. Okay, so 2q2 is p2. Now notice here, look here. P2 is equal to 2Q2. What is this number? It's an even number. Because this is an even number and P2 is equal to an even number, the only way P2 can be even is if P is even, right? So from here I concluded that P2 is even, and from there I conclude that P is even. So a number to the power of 2 is even if and only that the original number is even, right? When we're talking about natural numbers. Okay, so from this I conclude P is equal to 2k for some other natural number, right? P equal to 2k. So what is P2 then? P2 is equal to 4k2, right? Just raising both sides to the power of 2 again. Okay, now let's replace this equation here. So I'm just going to replace P2 there. I conclude 2q2 equal to 4k2. Now I can simplify 2 from both sides. I get what? q2 equal to 2k2. Okay, that's great. I got q2 is equal to 2k2. What does this say to me? Again, I see that q2 is equal to an even number here. So with the same argument I just made, is q is even. Okay. Now look at these three things I got. Q is even. Already I had shown that P is even. But remember what I said, what I assumed at the first. I assumed that only one of P and Q are even. So these three are contradictory. These three cannot be true in the same time, obviously. So I get a contradiction. And this means that my first assumption that the square root of 2 can be written as p over q was a wrong assumption, which landed me in the contradiction land. So I conclude that square root of 2 is irrational. Okay, so that was pretty simple, guys, but believe it or not, this was once unknown to the people. And I think Pythagoras, for example, he thought that the guy with the Pythagoras equality, he thought that every uh, number is actually rational. So once we see the proof, of course, it's become easy. Alright guys, thank you for watching and see you in another video.